So yesterday on Sunday, I saw Ted ski at Solden, and it was pretty impressive. And he won by a wide margin. And you can look at the results sheet, and you can see that his winning time was 2:36.02, and then Manfred Molg was 2:38.77, and then the last guy, Christoph Nosig, was 2:41.83. But the question is, how do I think about that? And I'm a math and science teacher, and so I wanted to think about how I could represent it as sort of a graphically. And so I came up with a graph. This is sort of what I came up with for you guys. This isn't what I did originally, but basically that blue dot right there, that's Ted. And then that's Molg right there. That's Hirscher, and that's the rest of the field. So and this on this line, this is seconds back. So this is all the rest of the field, and this is Ted out here. For comparison, I put the women's race from Saturday. So there's Tina out at front, and then we have the rest of the women's field going back to last place, just under 6.5 seconds back. And so you see that there's gaps, and they won by first and second sort of did well, but it's much bigger distribution, and not just this big, huge layoff between first and second. But the one thing that was missing out of this, the most important thing in ski racing is this idea of time. And time was somehow missing from what I was doing. So I decided to create a sound file, and believe me, I can do this quicker than you can. I decided to create a sound file where basically I put a 2.5 millisecond beep, 25 millisecond beep that's perfectly aligned with their finish times. So of course I cut out the 2 minutes and 40 some odd seconds and basically started my first beep with Ligety. And so this is what it sounds like. And I encourage you to go to my website in a little bit and get to the better sound files and listen to them with a headphone. So this is what it would sound like if you were listening to, say, a finish eye beep as they all came through.
The test begins. This is the end.
So you have Ted finish, then you've got a 2.7 second interval, and then the rest of the field finishes in 3.1 seconds.
The test begins. This is the end.
Okay, and once again, for comparison, here's the exact same thing for the women.
The test begins. This is the end.
Now, the other thing that was sort of raised by this was just the idea that it's really crazy when you think about it, that in a World Cup, first place to last place is under 6 seconds. First place to last place is under 6 seconds. And if we had some way to sort of run them all on the same course at the exact same time and did some sort of mass start, but made it so that they could ski through each other and wouldn't have to check their speed, and they could just go as fast as they wanted. If we started them all at the exact same time, this is how they would all come through the finish line.
This is the end.
That's pretty tight when you think about it. So I decided to sort of take this video and make it into a website. So you can go to bmaphysics.net/Ligety, and you can listen to the sound files with your headphones on, and it sounds a little bit better. And thank you for watching.